NEET Enlite channel, and today we are going to solve some amazing problems based out of NCERT as well as for NEET 2023 exams from the chapter of capacitors. Are you ready to solve some amazing questions with me, Shreyas, your physics master teacher at Vedantu, going live? Let me know how you guys are. Let me know what's going on in your life. Let me know how are your school midterms or unit tests or quarterly going on. I would love to help you out with any kind of problems or any kind of exams that you guys are facing with. Even if you're watching it recorded, you can put it up in the comment section. So let's begin with the session, guys. And if you want to know more about me, you can definitely read this, and you can also be my friend on Instagram. That's captain_Shreyas. That's my Instagram handle. Alright. So before we begin, I hope you have smashed the like button as well as hit that subscribe button down there, because that's the only way you are going to get all the important updates, notifications, upcoming classes. You will be able to follow these regular series on this channel, and this is an English medium channel. So for all the English speaking students or who are studying in English medium, this is like a boon for all of you. Okay, so let's begin with the class. Good evening, Komal. Hi Vivin. Hi Shivani. Hello Ganesh. Nice to see you guys. So many regular students are there already. Hello Nishri. Hello Ritesh. Hello Madhusudan. If you are a JEE student, you can definitely watch it for JEE mains. Yep, you can definitely watch it. Maybe the average and the simple questions can come from here, but not the difficult ones. At least for the average ones you can watch. Alright, so let's begin. Alright Ritesh, just leave a comment. Maybe I will definitely look into it. Hello Kids Universe. Okay, so here is the first question. Let's see how many of you are able to do it. Whenever you get the answer, make sure you put it up immediately in the chats. And if you're watching it recorded, make sure you are not seeing the solution before checking it, before actually solving it by yourself. Okay, so the first question says that there are two plates of a capacitor. One is at 10 volts, one is at minus 10 volts. So this is at 10 volts, this is at minus 10 volts. And one side the charge is 40 coulomb, other side the charge is minus 40 coulomb. The question is, what is the capacitance? Remember, when I say Q is equal to CV, this Q is charge on any plate. Any plate. This is the charge on any plate. C is the capacitance, and V is always the potential difference. So the charge on any one plate, magnitude wise, is technically speaking 40. Capacitance I do not know. A lot of you might be thinking the voltage difference is 10. No, it is 10 minus of minus 10, which is actually 20. So the capacitance will be 2 farad, which is nothing but option A, of course. No, it is not B. Some of you would be thinking it is 10. So 40 by 10, you will get it as 4. Many students also wrote 4. No, it is option A. Hello Somnath. Welcome all the new warriors. Ritesh, the Newton's second law formula. Well, I have already conducted a nurture series. Watch my nurture series playlist. It will be very useful. And yes, in the days to come, I'll be doing additional concepts, problem solving, hidden tricks and tips on all the important chapters, concepts of our both 11th as well as 12th. Okay, don't worry. Okay, next question coming up on your screen, and here it is, my warriors. Let's see how many of you are able to solve this. When a capacitor is connected to a battery, what do you think happens? A current flows in the circuit for some time and then goes down to zero, or no current flows at all, or an alternating current flows in the circuit, or a constant current flows in the circuit. Hello Amit, welcome. Definitely Ritesh. Please watch the previous recording. It's called as the nurture series. So what do you think is going to happen? Come on, figure this out. If a current is flowing in the circuit, if a capacitor is connected to a battery in the circuit, then what happens? So the moment you connect a battery to a capacitor, what happens is there is a slow increase of the charge on the capacitor plates. So one positive, one negative, that means the current will flow, and eventually the capacitor will get charged, and once it is charged, no more current flows. In fact, if you draw the graph of current with respect to time, the graph looks somewhat like this. So you can see that eventually it will become 0. And if somebody draws the graph of charge versus time, the graph looks somewhat like this. Here it becomes concentrated or it becomes steady. Final charge this is. So eventually the current drops down to 0, or I can say the charge ultimately achieves a steady value. So hence there is a current which will flow for a small time and eventually it will decrease to 0. So hence the answer is A, and I can see Akash has answered correct, Komal has answered correct. Very good. Hello Rashmi Sheikh, welcome aboard to the Enlite channel for both JEE as well as NEET aspirants, and that too in English medium. And this is your Captain Shreyas. That's where you can be my friend right over there. That's my Instagram handle. Ready for the next question on capacitors, and here it comes, my warriors. But before that, make sure you have checked the description box link to join the Telegram channel. I'll be updating the entire PDF so that you can solve even later on, and you can also scan the code so that you join the awesome Telegram channel where you get all the handwritten solutions, all the PDFs, all the updates, all the important news for your examinations. Okay, so let's start with the next question coming up on your screen, and here it is. The capacity of a parallel plate capacitor is dependent on what? Condenser capacitor is one and the same thing. It's nothing but an energy storing device. Come on, my warriors, let's see how many of you can use, how many of you can find the correct answer. The capacity of a parallel plate capacitance. So if this is, let's say for example, the parallel plate capacitor, these are the two plates, these are the terminals. So come on, think about it. I think the distance, area, and whatever is there inside, all that matters, because the capacitance formula, as far as I can remember, is epsilon naught K A divided by D. So yes, this D is nothing but the separation of the plates. Area of the plates not given. Thickness of the plates does not matter. See, this thickness doesn't even matter. This thickness has nothing to do with it. The metal which you use does not matter, but what you fill inside matters. That is basically the dielectric. So if I fill some material inside, then the medium inside matters. Now whether the plates are made of copper or aluminum or iron or steel does not really matter, because the charges are only on the surface of that conductor, that's it. So it really doesn't matter. And a lot of people think, sir, Q is equal to CV. So if voltage is increased, capacitance decreases. No, that's not true. That's completely incorrect. If voltage is increased, capacitance does not change, the charge changes. Capacitance depends only on the medium inside and the geometry and the shape and the size. That's all. Hence the correct answer to this question. How many of you given the correct answer? Very good, Komal. Yes, NEET also these questions will come. Bandli Mudi Sriharsha, definitely. Okay. So yes, very good, Kids Universe, very good, Madhusudan, very good, Nishant. Awesome, awesome, awesome. Manikandan. Oh, Manikandan, no, it's not C, it is option D. Background noise is there. I think I can't avoid it if there is any. I think it is little bit, but I think it is manageable. Just concentrate on the lecture, guys. Don't worry. Okay, that noise might come and go. I'm not in the studio setup, Bhargav, for a few days. So next 1 week I will not be there. So again after that I will be back. Okay. So the capacitance of a parallel plate capacitor is 12. The distance between the plates is double. Area is halved. The new capacitance will be, the distance is doubled, area is halved, the new capacitance will be how much? Come on, I want the answer within 20-30 seconds. 20-30 seconds. So figure out the correct answer. If you know the formula of parallel plate capacitance, which is epsilon naught A by D, you will be easily able to arrive at the final answer. It's clearly mentioned that the distance is doubled, so the denominator is doubled. The area is halved, so hence that 2 and this 2 will get multiplied, so hence the capacitance should become 1/4. So the new capacitance will be 12 microfarad into 1/4 of it, which is obviously 3 microfarad. And how many of you have given the right answer, my warriors? Very good. Komal, Hari Prasad, Shalini, awesome. Awesome, Sri Harsha. Very good, Nishant. Very good, Madhusudan. Excellent. Proud of you guys. Proud of you. Keep it up. So these kind of questions do come in NEET, and when you are able to solve this fatafat, That means your chances of getting 150 plus also increases. NEET exam is not difficult exam like JEE Advanced or Olympiads or KVPY. It is slightly below mains and you have many questions to be solved in less time. So it's all about how you can improve the speed. Are you able to recollect the formula? Are you able to apply the correct formula? Can you avoid silly mistakes? Can you do the calculations fast? All these things will matter. Here is the next question coming up on your screen. The parallel plate capacitor is charged to a voltage of V. Now you disconnect it. Okay, you are disconnecting it. The distance between the plates of the capacitor is increased using some handle, insulating. So why insulating? Because if it is a conducting, maybe that conductor will take away the charge which is already stored. Now what do you think will happen to the voltage difference between the plates? Kailash, you should be early, bacha, 7 o'clock, Shreyas sir. And also make sure you have hit the bell icon so that you get the notification. And yes, please hit the subscribe button and the like button, because that's the way YouTube will recommend you the video whenever I'm conducting next. And also it means a lot when you smash that little like button out there. Thank you very much. Okay, so what do you guys say? First of all, you are charging the capacitor to some voltage, okay, and because of which there will be some charge on the plates. Now you disconnect it. The charge has nowhere to go, so the charge stays there as it is. Now you are basically increasing the distance, so the charge does not change. The charge does not change. So I can say in this question, Q is constant. Q is constant. Do you guys agree with this statement? The charge has nowhere to go. Where will it go? You are just pulling it using insulating handles. There is nowhere to go. So charge will not change. And what about the field? Field is Q by A epsilon naught. So Q did not change. Area did not change. Distance changed. Epsilon naught is a constant. So I have a feeling that the field is also going to be a constant. Oh, now this is interesting. The moment field is constant, I can use this formula. Electric field is voltage by the distance. E did not change. Distance has increased. Naturally, to keep the ratio same, voltage also has to increase. Hence, that is option B. Love, you got the wrong answer, guys. That's why you should attend Captain Shreyas sir's classes. Everybody got it wrong. At least the ones who are attending it live. If you are watching it recorded and you get it right, good. Else, many students, -1, -1, tuck, 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 you will lose 4 marks. Why? Because you were supposed to get 3. You got -1. It's a loss of 4. Because you invested time in solving the question. So ideally you should have got the 3. So it's a loss of actually 4 marks when you get -1. Okay? So is that clear? The field did not change because charge did not change. The field is dV by dr, voltage difference by distance. So hence voltage increases because denominator also increases. Is everybody getting it? Understood? Clear? Can we go to the next amazing question? Let me know, guys, in the chat box. Put some heart. Let it rain with some fire. And comes the next question up on your screen. The electrostatic force between the metal pieces of an isolated parallel plate capacitor having some charge Q and area A is proportional to what? Interesting question. Yes, Yogita is saying, sir, I have a doubt. How is the potential increase just because of the increasing distance? Okay, so think of it like this, Yogita. The two plates are oppositely charged, positive and negative. Okay, now they will attract each other. They want to cling and stick to each other. But you are doing some work by pulling them apart. So it is your work which has gone in increasing that potential difference. Think about it that way. Okay, or else it was stuck. So you are pulling them apart. You are applying some force to pull them apart. That's why that force is causing that increase in the potential difference. But technically, you can look at it the field way. Field depends on voltage by distance. The longer the field has to travel, the more the potential will fall. So the moment you increase the distance, the field has to travel for a long distance. So because of which the potential will keep falling by a large amount. Is that fine, Yogita? Okay. So Madhusudan saying option D. What about others, my warriors? Come on, figure this out quickly. So we have electrostatic force What does it depend on? I have a feeling it is independent. No, Madhusudan, it is not D. The force between the plates of a capacitor is given by Q square by 2 A epsilon naught. There is no mention of D. In fact, it is independent. Independent. There is no D. There is independent of D. It depends on the charge square, inversely proportional to area, and there is a 2 and epsilon naught. Hence, the answer is C. Remember, the field is uniform. The field is uniform. Whenever you have uniform field, the strength is same everywhere. So it's not like when you go far away, the strength reduces. The strength remains the same. That's why it is option C. Is that understood? Can we go ahead to the next question? Great. Let's go then. Look at this question now. There is a oil drop of certain mass. It's in space between two plates, each of area 2 into 10 to the power minus 2. Now the upper plate has some charge. The lower plate has an equal negative charge. The oil remains at rest. The charge on the drop is how much? Interesting. So just imagine if there is some kind of a mass, okay, which is just staying at rest. That means the gravitational force mg must be balanced by some force so that it stays basically at rest, and the only force which can balance it is the charge into the field force. That means the electrostatic force, electric force which is there. And how will the electric field force come? Because there are two plates, and obviously let's say there is some kind of a field between them, between these two plates, and because of this field which is there between the two plates, it definitely applies some kind of a force on the charges. So I can say at rest or at equilibrium, QE is equal to mg, and I want to find the charge on the oil drop. So Q will be equal to mg by E. But wait a minute, this electric field between the two plates of a capacitor, I think I just told you also, that is Q by A epsilon naught. Charge by A epsilon naught. Okay. Hello Yogita. I'm Shivan sir's student here. Wow, very nice. And Shivan sir's birthday is also there today. I've heard a lot about you. Thank you so much, Yogita. And I hope you guys keep learning from all the sources, all the resources that are there. Make the best use of it. All the amazing teachers are there here at Vedantu to help you. Good evening, Rocket. Looks like your name is inspired from the movie Rocketry. Now it's just a matter of substitution. Mass is 2.5 into 10 to the power minus 7. Gravitational acceleration is 10. Epsilon naught is 8.85 into 10 to the power minus 12. Area is nothing but 2 into 10 to the power minus 2. And then last one is charge. Charge is 5 into 10 to the power minus 7. Everything is given. The charge on the plate. So here maybe there is plus Q charge. Maybe here there is minus Q charge, because of which there is a field. Solve this and you will get the answer. From what I can see over here clearly, I can see a 2 over here. I can see 2.5 over here. 2.5 into 2, 5. 5 and 5 from the top get cancelled. So I now can see only powers of 10. So solving this, I think you should get the answer. Just check it out. I think only 8.85 will remain. 10 to the power minus 7 and 10 to the power minus 7 also gets cancelled. That's it, my warriors. And you should get the answer as into 10 to the power minus 13, which is option C. By the way, do you know what is this problem inspired from? How many of you know what is the inspiration behind this problem? Let's see how many of you have been reading a lot of stuff. What's the inspiration of this problem? This problem is inspired from a very famous experiment, which is called as, come on, hello Saint Tyson. Yes, it is called as your Milkman oil drop experiment. Oh, nice to see you, Rocket, here. Very good. Rocket is there everywhere. Good. Welcome, Bacha. Welcome. Good. I'm so glad you're enjoying it. Milkman oil drop experiment. Basically, he suspended oil drops and he suspended different sizes, and he saw that there were oil drops which were suspended at equilibrium, and he calculated the charge using the same formula, and he found that the charge was always a multiple of a certain value, and that value was 1.6 into 10 to the power minus 19. So he did this experiment multiple times and he found that it was always the multiple of 1.6 into 10 to the power minus 19. Excellent chemistry, atomic structure. So this is a very famous experiment, guys. This is the working principle behind it. And you just solved it like a problem. Kudos. So the next question is, the capacitance of a metallic sphere is 1 microfarad. If its radius, no, I think it should be like, its radius is roughly how many meters, centimeters, kilometers? Yes, it is that one exactly, Yogita. Great. So what is the answer to this question? Now let me tell you, whenever you have just a sphere, okay, just a sphere of radius r, and you charge it with some charges over it, even that sphere is going to act like a capacitor. Although the field lines technically end at infinity, you can think that the whole space around it is going to store the energy. This is often called as isolated capacitor, spherical one, isolated capacitor. And such a capacitance is 4 pi epsilon naught r. That's the value of the capacitance, my warriors. So it is 4 pi epsilon naught r. I think the question is find the radius, so it will be 1 by 4 pi epsilon naught. C is there on the top. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. The capacitance is 1 microfarad, so I think it should be 9 into 10 to the power 3 meters, but I can see kilometers, which is option A, of course. Alright, so many people forget this formula because you generally remember epsilon naught A by D, or the cylinder formula, which is 2 pi epsilon naught length divided by log of A by log of B, or some people also remember the concentric spherical formula, which is 4 pi epsilon naught 1 by A minus 1 by B, but many people usually forget this. That's why you have to attend the classes over here. Okay, understood? Clear? Amazing. Moving on to the next question. Sir, for 1 year repeater course will be for NEET. I want to take long term. Yes, Bandalamudi Sriharsha, there is a long term NEET course. Just leave a comment after the session is over. I will send you the link of the NEET long term dropper batch exclusively for NEET. Both languages are there, English as well as Hindi. So you can choose whichever language you want to join into. Okay, pure English is also there. Now next question. 8 drops of mercury of equal radius possess equal charges combined together to form a big drop. The capacitance of the big drop compared to each small drop is how many? How many times? Come on, figure this out. Come on, guys. 8 drops of mercury, 8 drops of mercury combined together to form a single drop. So imagine those small drops, which are basically 8 of them. They combine together. Let's say the radius was just r, combined together to form one big drop of radius, let's say r. Then volume will be conserved, obviously. So I think I should first find out the radius, only then I can solve this. So I can say the volume of the small sphere will be 4 by 3 pi r cube, right, into 8 will be nothing but 4 by 3 pi capital R cube. 4 by 3 pi, 4 by 3 pi will obviously cancel, and I can also look at it as 2r whole cube is equal to capital R cube, because 2 cube is 8. Naturally, r will be just 2 times of r after taking cube root on both the sides. Now why is this important is because once I find this out, I can use the capacitance formula which I just gave you. It is 4 pi epsilon naught into radius for an isolated sphere or a drop. So if the radius is being doubled, obviously the capacitance is also being doubled. Hence the answer is option C. Who is correct? Who is correct? Or roll rocket. Hello Saja, welcome aboard. Hi student. Komal, yes, it is correct. Jayashree, I'm looking dull, is it? It's maybe because I'm not in the studio setup, bacha. Here the lighting is not that exclusive, and I cannot have these tube lights on my face so much, and that's the reason. And maybe I did not shave. That's why, maybe. Who knows? Okay. Yes, yes, volume chapter. You combine multiple geometries together. Back in 9th or 8th grade, you would have done these kind of questions. Yes, very good student, finally. Yes, very good Manikandan, very good Juhi. Awesome, awesome. Alright, so I know even I am eagerly waiting to get back to my studio, guys. And there I have my big screen. But you know the best part is, even though I have come to my hometown, I'm able to connect with you. And that's the best part. Otherwise, imagine if I was in offline, or if I did not have this facility of online, a setup where you can go anywhere and teach. I am pretty sure you would have had a big gap of classes for long days. At least few days I can come and conduct the classes over here. Yes, Jayashree, I have eaten. Yes, I have eaten. Yep. Okay. So, thank you so much, Jayashree, for asking. It shows your immense love for your teachers. Thank you so much. It means a lot. You asking such a small thing, it made my day. Thank you so much. Rocket in Vedantu, is there any separate course for 11 JEE? Yes, there is. In fact, I am only taking that 11 JEE course. I am also teaching for 12 JEE. Okay. So many people are saying unchanged. Is that so? Let's find out. So Rocket, you can just leave a comment after the video ends. I will ping you the link for joining my 11th standard JEE course also. Why is unchanged is because, see, if you have just a capacitor without such an AI strip, aluminum strip, so basically, fair. This is your aluminum strip. This will be the charges on one side, let's say. This will be the charges on the other side. In the case of aluminum strip, this will be plus, plus, plus. This will be minus, minus, minus. And the other side will be plus, 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 and minus, minus, minus. If you notice, the electric field lines will travel from positive to negative in one continuity. Here, there will be a small break of the electric field, but that break is so small, it's hardly to be seen. It is as if it is continuous. So, the field is same. The field is same. The charge is same. The charge is same. The distance is same. So naturally the voltage is also going to be the same. Maybe you will not be able to see it. Yeah, you are seeing it. Okay. Therefore, the capacitance is also going to be the same. Is that clear? Okay, great. Definitely, Rocket. Leave a comment after the video ends. You cannot comment when the video is going on. When the live video is going on, after the live streaming ends, leave a comment. I will pin a link or reply to your comment. Okay. When did you JEE 3032? When did you start JEE 2023 on YouTube? Jack. Okay. I was wondering. Jack is from the future. So 2023 in YouTube, I started quite some time back. It is called as the ultralegend series. So ultralegend is for basically 12th standard. It is this year's live classes, but let me tell you, my warriors, there is also an option for all of you to watch my last year's classes. Please watch that. It is called as the Pathfinder series for 12th, and for 11th it is called Nurture playlist. Watch it. All the playlist is complete for physics. You will see all the chapters, all the important concepts are being covered. Anything extra, I'll be doing it this year. Okay? Fair. Moving on to the next question. Good evening, Harshavardhan. A battery charges a parallel plate capacitor separated by some distance, and there is some energy stored in it. You add a slab of the same thickness once when the capacitor is connected, second when it is not connected to the battery. What will be the new energy of the system? Okay, let's try to understand what is exactly happening, my warriors. First of all, imagine that you have a capacitor. And it has been charged by a battery. Okay, that means there will be some charge stored on it. Let's say that charge is Q. Okay, and there will be some field like this over here, and this is your distance d. This is your distance d. This is how it is. Now there are two situations. Let's take the situation number 1. Situation 1 is when the battery is still connected. So I'm just going to draw it over here. The battery is still connected, and what you have done is basically you have added a dielectric slab inside it. So you have filled some medium inside of it. So that is the dielectric medium, like this. Okay, I hope everybody can see this. I hope everything is clear. Now let me go back a little bit. Initially what will happen is that there will be some potential energy stored, and you can use either half CV square or you can use half Q square by C, whichever you feel like, depending on which formula will be more useful. Now in this case, especially the first one, when you notice, okay, I think I'll have to move a little bit on the side. Okay, so this is basically your initial energy U naught. Now when you add a dielectric slab with the battery connected, the voltage will be constant. And the moment the voltage is constant, think about it, I can use the formula U is equal to half CV square. V did not change, but the capacitance increased K times. Capacitance will definitely increase K times. That means the energy stored will also increase K times. Hence, the new energy in the first case will be K times of the original energy, which is U naught. Is that understood? Why I have used half CV square? Because I know voltage will be constant, because you are still maintaining that voltage by connecting that battery. But I don't think that will be the case for the second one, when you are disconnecting it. The moment you disconnect, it is the charge which cannot go anywhere. The charge stays as it is. So whatever charge was there, it has nowhere to go. So the charge is basically going to be constant. And let me just add the dielectric slab over here, like this. This is that medium which is present. In either case, the capacitance will anyways increase, but you will see that the manner in which it affects the energy is different. This time I don't think I will use U is equal to half CV square. Q is constant my warrior, so I am going to use half Q square by C. Now numerator is constant, the denominator increased K times. Naturally the energy stored will change 1 by K times. Naturally it will change 1 by K times. So hence the final energy will be the original energy divided by K. That is the final answer. Yes, Gautam sir. In fact, you should do that, bacha. You should focus on your coaching, and if you develop enough backlogs, or if you feel that I think I should concentrate on a chapter, then please, I try to avoid your school studies or college studies and concentrate completely on your JEE or NEET studies. Ultralegend is for all the subjects, bacha. Okay. Shall we go ahead, my warriors, to the next one? It's a beautiful question. Like you can see, it becomes K times or U naught by K. Depends on whether it is connected or disconnected from the battery. So you should read the question very, very carefully. That's what it says. Next question coming up on your screen. What do we have? There is a slab of copper somewhere in between a parallel plate capacitor. The slab of copper, it's a conductor, is exactly half the distance. What is the ratio of the capacitance after adding and before inserting that slab? Let's try to solve this question. First of all, this is before. Before adding anything, it would be just a normal parallel plate capacitor, so it will be epsilon naught A divided by D. And the moment you add this copper over here, things will change slightly, because electric field will only travel over here, In fact, there will be no field inside the copper. E in that copper will be 0. So I think the effective distance will just become D minus B. In this case, the B value itself is D by 2. So the effective distance will be D. Earlier, the field used to travel from one plate to other. Complete distance D was involved. Here only it is traveling for just D by 2. right? So D effective will be D by 2. So hence the C nu will be epsilon naught A by D by 2. So I think you just have to take the ratio of both of these quantities. So just divide them. I think it is after C nu. Oops, 1 second. I think the way they have asked it is C nu divided by C before. So obviously it's going to be epsilon naught A by D by 2 divided by epsilon naught A divided by D. So I think it is going to be 2:1. That is option number B, of course. Nope, Komal, it is not C, it is B option. Be careful, this 2 is there. Here the 2 is not there. So everything else will get cancelled. Only the 2 will remain. Epsilon, epsilon, A, D, D. Do you see this 2 is remaining? This 2 is remaining. And the 2 comes right over here in the numerator. Okay, is that clear? It is not 1:1. A lot of people make that mistake. Oh, I think you are not able to see that D effective as D by 2. My head was blocking it. Oops, my bad. So it was D by 2, my values. Okay, great. In college you got 180. I mean, I'm not understanding Gosdar. Is your college also conducting JEE tuitions or something? Okay, moving on to the next one coming up on your screen. Now here we have two slabs, one after the other. One slab actually is air only, D by 2. Other slab is having dielectric constant of 2. Question is, what is the net capacitance? Beautiful question. Let's see how many of you are able to solve this question. Come on. There is a beautiful formula for such kind of questions whenever you have multiple slabs, and I'll give you that formula, then you can just substitute. It is nothing but epsilon naught A by, it is nothing but D1 by K1 plus D2 by K2 and so on and so forth. So all the D1, D2, D3s are the distances where that material is present. That's all. So now just solve this, you will get the answer. So epsilon naught A by D1 is just D by 2, K1 is just 1, plus D2 is just D by 2, K2 is just 2. So it is nothing but epsilon naught A by half D plus D by 4. D by 2 plus D by 4 is 3D by 4. So hence it shall become 4 epsilon naught A divided by 3D, which is obviously option A. Very good, Goxdar. Hello Abhishek, yes. No Yogita, it is option A. So use this formula whenever multiple slabs, even if there are 3, sometimes there is a gap and there is a slab, even then you can use this formula. Many students had some weird formula, D minus T plus T by K. You will forget where was that K, where was that T. It's confusing. Stark, I was born in Tamil Nadu, Salem. Yep. But right now I'm in Bangalore. Okay. Education done from Pune and Nagpur and Bombay. So mixture bacha. And I hope that you too visit all the places, not just in our country but also abroad. You should travel the world, you should travel the country, you should get a lot of exposure, guys. Okay? So in the college they conduct JEE. If they conduct JEE, then I feel that okay, I understand they might have their own targets. You believe in yourself. I remember even I had joined some correspondence and I was also a part of coaching. So I was not able to understand too much in my coaching. So I was following the correspondence course and I was doing well there. And slowly I was building confidence. So I know my coaching was pressurizing me at that point of time. Why are you not doing that? Why are you not doing this? Oh, you're not getting good marks. But what happened is, because I was consistent and I was believing that, okay, you know, this is what I'm doing right and I'm doing things in the right manner. I had set targets and I was achieving that. So I did not bother. Eventually what happened when the entire syllabus was complete and my revision started, that's when I did well in both the institutes. Well, my correspondence as well as my coaching. So it happens. So eventually you will do well when the final exam comes. Don't worry about it. Okay, bacha? Let's move on to the next question. No, I did not take a drop. Okay. So aim to aims, I cannot be everywhere, right? Like a teacher can only do so much. I can be present only at one place at a time, and already I'm on 2 channels on YouTube. I'm taking 11 JEE, I'm taking 12 JEE, I'm taking the Manthan batch, the AI batches, all the AI batches for JEE, you will find me. So that's why I cannot be everywhere. But yes, you have the best teachers no matter in whichever batch you are. 4 capacitances equivalent capacitance when in series is C1. So C1 will be nothing but I think C by 4, because since 1 by C, 1 will be 1 by C plus 1 by C plus 1 by C plus 1 by C. So it will be 4 by C. Flip it, you are going to get this. C2, because it is in parallel, it will be C into 4, because C2, since C2 will be C plus C plus C plus C. It's exactly opposite of resistors. It's exactly opposite of capacitors. Bandmulji, Shreyas, I think at least 1 to 2 questions can come from current electricity capacitors chapter. Very high weightage actually. And you should not think about what is the weightage right now, because now is the time you prepare for everything. Weightage is for those people who have not prepared throughout the year and then they worry about what is the weightage of this chapter because they have to get some marks. So right now you prepare for everything, you have time. So you just have to find the ratio of C1 by C2. Obviously it is C by 4 by 4C, hence it is 1 by 16. Awesome. Option B, correcto Komal, Kids Universe, Shri Harsha, Vidya Muthu, awesome Gogsder, very good, very good. Yes, we always keep thinking about what the others have done and we forget that everybody has different situations. Very true, very important, true. So we cannot have a uniform formula for everything, right? Good. Opposite of resistors, exactly, exactly. That's why this question was there. Actually, this question is not good. I'll tell you why. The options are not made well. There should have been one more option, which was 16:1. Okay, if that option was there 16:1, then many people would have had 16:1, because generally people use resistor formula. They forget in the hurry-burry of the exam, they make this silly mistake. Wow, V.S. Kaushal, you're listening to my lecture from London. Hi, Bacha. I think it should be afternoon. Yeah, early afternoon out there. Awesome. So you guys also have similar syllabus out there in London, or are you preparing for NEET or JEE? V.S. Kaushal. Is there enough time for 2023? Yes, Gauthar, there is. Trust me, there is. If you plan, strategize, block strategy, and meet your small targets such that you complete most of the things by December, you have time. Okay. 3 capacitors, each of capacitance C. The breakdown voltage V are joined in series. The capacitance and the breakdown voltage of the combination is how much? Mere mastak tha. I didn't get that, Juhi. Okay. So, very good, Yogita. That's the catch. Many students just watch the formulas. No point. Okay, let's try to solve this. Each capacitor has a breakdown. What do you understand by breakdown? Breakdown means the maximum capacity, voltage-wise, of a capacitor. Each capacitor can hold a voltage of V each. So, as a whole, the total voltage that they can hold is 3V, because they are in series. In series, the voltages will add. Correct. And CS will obviously be C by 3, because they are in series. In series, you just divide, in parallel you add. Remember that. Okay, it's reciprocal, it's opposite. Hence the answer will be option C for Captain Shreyas. The 2023 NEET repeaters batch Suman Sohu has already started. There will be link in the description box. If there is no link, leave a comment. I will reply to your comment for whichever batch you want to join. Just let me know. You can also contact me on captain_Shreyas. Okay. Abhishek, now is the time you focus on the subject which you struggle a lot, because you have time. So please focus on your weak points right now. Okay, not on your strengths only. Strengths, you do it when you get bored. Now I'm bored, I can't do anything, I'm tired, I feel exhausted. Then do your strengths, because then your brain will get activated. Then you will feel like, okay, let me solve more problems. Okay, this is done. Then again, once you get energized, then solve the difficult or the not so interesting chapters, or whichever your weak points are. Okay. The charge on any one of the capacitors is, okay, I think I need to make myself small. Okay, I think this small is fine. Okay, Great. So let's try to solve this question, my warriors. Try to figure this out. Now, in these kind of questions, whenever charges are asked, try to reduce the circuit and again come back from the reduced circuit. So what do I mean by that? Like you can see 2 microfarad and 2 microfarad over here are in series. So here is what I will do. I will just probably take this 1 microfarad capacitance as it is. It's connected to our 2-volt battery right over here. Okay, this is 2-volt battery, and on the top I can see that there is one equivalent capacitance which I can consider because they are in series. 2 micro and 2 micro will together give not 4, be careful, not in series resistor formula, parallel resistor formula. So it will be 1 microfarad because they are in series. Keep this in mind. These two are basically in series. Great. Now this one and this one are now in parallel. So I can just combine them together into one capacitor alone of 2 microfarad, and this would be 2 volts, of course. Now you can find the charge on them. The charge will be CV, so 2 micro into voltage, so it will be 4 microcoulomb. Correct? Now once the charge is found on the parallel part, remember the 1 micro and 1 micro are parallel, they will have some charges individually. Their charge when added together will give 4 micro. So technically speaking, this 4 micro is getting split into 2 of them. So in parallel circuits, the charges added. In series circuit, like you can see over here, the voltages get added. So in series, V1 plus V2 plus V3 is the total voltage. In parallel, Q1 plus Q2 plus Q3 is the total charge. Luckily for us, the charges are equal because the capacitances are equal. So here there will be 2 microcoulomb and this will be also 2 microcoulomb. Now when you split it backwards, remember in series, charges are same. Charges are going to be same. Hence you will see each of these 2 microfarad will have 2 microcoulomb, and this will also have 2 microcoulomb, and this 1 microfarad, anyways from here only you can see this has 2 microcoulomb, so this will also have 2 microcoulomb. So 2 and 2 is the answer, which is option D, of course. Did you see that? Alright, great, option D it is. Yes Juhi, yes Gauzer, no Komal, happens, no problem Vidya. Hello Rashmi Sheikh. Good evening Bachalo. Yes. The isolated system, how charge is conserved in capacitors. So Gauzer, basically you can think of it this way, there is no place for the charge to flow out. So that's the reason why the charge is conserved. If the charge is connected or the capacitor is connected to some external circuit or some battery, then the battery will supply some charge or something like that. But here in isolated, not this problem, in some other problem, there is no other place for the charge to go. Next question. In fact, this is also a nice question where again the charge is conserved. Alright, Gauzer. You can use KVL also, but KVL will be lengthy. I feel series and parallel circuits should be solved using only 2 simple concepts. First, in series, charge is same, voltages get added. Second, in parallel, charges get added, voltage is same. That's all. If you know this, more than enough, apart from the basic formulas. Now a 2 microfarad capacitor, let's try to understand what is happening over here. So we have a 2 microfarad capacitor, and this capacitor is connected using a battery of how many volts? 200 volts. So this is 200 volts. Naturally there will be some charge on it here and here. So how much will be that charge? It will be C into V. So naturally it is going to be 400 microcoulomb. Now the battery is removed. That means the next step, the battery is removed. So the charge has nowhere to go. So the charge stays there. It's an isolated system. If the battery was connected, it will change. But here there is no place for the charge to go. So it will just stay there. And I will have, not 200, it's 400. I will still have plus minus 400 microcoulomb charge charge will stay. It is conserved. Now what you do is take this capacitor and connect it to another uncharged capacitor in parallel. So you take this capacitor and connect it to another uncharged capacitor whose magnitude of capacitance is not known. This has charge, this doesn't. The moment you connect them, obviously the charges will flow till what becomes equal, my warriors. The charges will flow till what becomes equal. Let me know in the chat box. Something should become equal. It's clearly mentioned they are in parallel. Even if it was not mentioned, you understand this. You can see they are side by side. If you notice, their voltages will be same. In fact, it is given that the final voltage is 40 volts in parallel. So voltage will be same. Kalyani, your name rings a bell, but maybe long time. Gokulam Kanan, do not join the crash course, bacha, right now. Now is not the time for crash course. Now there is a batch for 2023, which is a condensed batch where the entire syllabus is taught, not like a crash course, but not like a long term also, where it takes 1 year to teach, in a condensed manner. So there is a 2023 batch for you. So Gokulananda, I would say join that batch that includes 11th as well as 12th portions. So 12th is taught, 11th portion is revised, and then it includes the crash course content also in the end, during revision, during mock test, all that is inclusive. Leave a comment after the video ends. I will reply to your comment. Okay, now you can see they are in parallel. This was how much? 2 microfarad capacitance. The charge will be conserved. So yes, if there was maybe so much charge over here, maybe this might have some charge left over here. The remaining charges might flow over here. Who knows? The charge will be conserved, right? And then I can convert it into one single capacitor. Maybe I should move my head. Yes, there you go. Whose capacitance will be C effective, which will be 2 micro plus C. That's it. And this will have the total charge, whatever was there. It's plus plus minus minus. That's it. And I know that charge was nothing but 400 microcoulomb. And I know the voltage is also 40 volts. So all you need to do is use Q is equal to C effective into that voltage. Q is 400 micro. Effective capacitance is 2 micro plus, oops, 1 second, 2 micro plus, sorry, what happened? 2 micro plus the capacitance. So let me just write it. 2 micro plus capacitance. Voltage is nothing but 40 volts. So this will become nothing but 10 micro is 2 micro plus C, right? And I can just write this down as C is equal to 8 micro coulomb. That's it. So, sorry, microfarad, my bad. This is microfarad. That's the answer. So option C is correct. Gokul Nanan, you need to check the dates. I mean, each batch has a different date. So I can just ping you the link. You can see that starting date will be mentioned over there itself. It has just started, I think, this week itself, if I'm not wrong. Okay, last Monday, this Monday only, I think it started. Okay, moving on to the next question. Wow, what do we have? We have multiple capacitors again. The question is, find the equivalent capacitance if each capacitance is how much? 9 microfarad. Now these kind of questions are usually disguised form. You basically need to rearrange these capacitors to get the new capacitance. So what you do is basically just rearrange them. How? Observe. What you do is take this point A and make it sideways. Open this up. Open this up. So point A is over here. And you will see that C2 capacitance is as it is. Then in front of it, you have your C3 capacitance. And C3 and that point A is connected with this C4 capacitance like this, I suppose. Yep, it is like that. And next, what else is there? Okay, There is one more capacitor between C2 and C3, and it is connected probably like this, and that is point B. So what I feel is I can shift point B wherever I want. Why to put point B on the top? Maybe it's the same wire. How about putting point B over here? Now it looks like a little bit simpler problem. Not so much, but little bit simpler. How to make it even more simple? Look at this. This is point A. This is your C2 capacitance. Do you notice C1 and C3 are actually in parallel? Did you just notice that? C3 and your C1 are actually in parallel, my warriors. So this is your C1, and you can see that C4 is parallel to all of them. C4 is parallel to all of them. Perfect. Now you know what to do. You just have to add them. Now each of them is nothing but 9 microfarad. So basically you can just combine these two together. Since they are in parallel, it will be 9 plus 9, which is nothing but 18 microfarad. And then combine these two also together. Correct? Combine these two also together, and this and this will be in series. So what can I do? Let's just put point A over here. Let's just put point B over here. There is one C4 remaining. This capacitance, I can write it as what is it? 9 into 18 divided by 9 plus 18, which is 9 into 18 divided by 27. This is nothing but 3. This is nothing but 6. Right? Yep. And finally, these two are in parallel. So eventually what will happen? It will just become one simple capacitor of how much value, my warriors? It will be 6 plus 9, which is 15 microfarad. Excellent. There you go. 15 microfarad is the answer. So you need to slowly convert it, make it look simple, and then reduce to get the final answer. Great. Awesome. Thank you so much. Welcome, cyber entertaining. Keep learning, keep enjoying, and keep scoring, bacha. Okay, I'm so glad that the channel is helping you and I'm helping you. Thank you. Awesome. Keep growing, bacha. I want to see you in a very good college in the days to come. Nisha, very late, bacha. Please watch the replay. I'm almost, I think, on the last question and maybe a homework question. Thank you. Oh, your name is Arshad. Thank you. Welcome, Arshad. How to not compare with toppers, sir? I can't control my mind. They are scaring you. Hyping. Okay. Meanwhile, others try to solve this question, my warriors. So I would say whenever you get scared by looking at marks of the toppers, or sometimes it's not just you, maybe it could be subconscious, or it could be somebody is trying to tell you about the toppers, maybe your teachers or maybe your family members are telling, see how that guy is scoring. Remember guys, it's not that only toppers do well in life. It's just a way to be doing well in a little bit easier manner. You do not have to probably put so much of effort if you are a topper in the initial days of your job, or because you get a good job or something like that. But there is nothing like all the backbenchers or the person who probably failed, or the person who was getting 60% marks, he does not do well in life. That's definitely not true. And I can tell you by my experience, I've seen so many batches. I have written JEE almost 17 years back, so I have seen life. It doesn't really matter at the end of the day. You will do well, but you should develop a skill. You should believe in yourself, and you should work towards the skills. Develop many skills, in fact, not just one skill. Everybody has your own talent. I'm not saying you become a musician or go into arts, that's your talent. Even if you want to go into medical, or even if you want to go in engineering or science, there are so many things. It's not just MBBS, or it's not just computer science, or it's not just artificial intelligence. So many things can be looked upon. It could be the business side, it could be the marketing side, it could be the sales side, it could be the consultancy side, it could be managing the business, it could be starting your company, it could be anything, it could be the research, it could be application, it could be actually operating. So many things are there. You do not know how you are going to do. So believe in yourself. There are a lot of things in store for you, and God has definitely kept all these things in mind for everyone. Don't worry. Okay? So please do not worry about your toppers. Fine. I have seen so many toppers just doing normal in life even now. Okay? I'm not saying that all toppers are like that, but I have seen many toppers just doing normal. And I was not a topper, I was an average student. But I think I'm doing quite well. I am enjoying my job. I love teaching. I love physics. I like interacting. I get to travel places. I'm teaching so many kids out here online, right? So it really doesn't matter at the end of the day. Okay, so let's see how to solve these kind of questions. I can see that there are 3 capacitors over here. Do you see that? There is one capacitor here. There is one capacitor here. One capacitor here. This is one capacitor. This is one capacitor. And this is also one capacitor. You can see that each capacitor is connected between A, B, B, A, B. So all the capacitors has the same voltage difference. Yep. Ayush, how about leaving a comment maybe, or maybe pinging me somewhere, or leaving it in the doubt app? I will definitely look into it. I cannot look at randomly like that. So Coxer, if you are looking at business and stock market, please go ahead with it. You should definitely go into IITs. There is a finance club in it. Finance club, and many of my students are the members of it, and even they're leading those clubs. So please go into it. So that's it. These 3 are in parallel. So C between A and B will be C1 plus C2 plus C3. So in this case, all of them are equal. So it is 3C. So it is 3 times epsilon naught A by D. That's all. There you go. Awesome. Okay. So whenever you see such things, try to think, are there any capacitors that I can see? Are they connected between some points? Oh, are the potentials same? Can I redraw the circuit? Are these capacitors just in a hidden manner? So you will be able to get the answer, which is option B in this case. Now this question I want to answer in the comments. Answer in comments below, and the answer as well as solution is going to be put up in the Telegram channel. Okay, so I'm looking forward for all your answers in the comment section. I hope you guys have enjoyed today's class. It was lovely interacting with all of you, and make sure that you have smashed the like button and also hit the subscribe button. Keep enjoying, keep learning. A lot of problem sessions will come, and I want your full support. If you do not like, if you do not subscribe, I'll think that maybe you do not like problems, so I'll maybe conduct some other thing. Okay, so make sure that you spread the word, get your friends also along for attending these classes, maybe even recorded, that's fine.